everyone. I am Dr. G. Prabhakar, Assistant Professor of Chemistry, Department of Basic Sciences and Humanity, B.V. Raju Institute of Technology, Narsapur. And the course is Engineering Chemistry. In that, the topic for today's session is fuels. What is a fuel? Any type of material which generates energy on combustion, which is called as a fuel. We have like several fuels are available. Suppose a wood is there. The wood on combustion, it produces some form of heat, energy, we can say some form of energy. That energy is liberated in the form of heat. So it's a fuel. Or else some faded leaves are there. On combustion, that faded leaves also generates energy. So it may be considered as a fuel. So meanwhile, a fuel is a substance containing carbon in it. Actually, what is the major constituent which leads to that combustion? That is carbon. So a fuel is a substance containing carbon as a major constituent which provides energy on combustion, which is called as fuel. Then what is this process combustion? Combustion is an oxidation process. In presence of oxidation, which generates heat, so which is called as combustion. So finally, a fuel is a substance containing carbon and which releases energy on combustion, or the combustion is nothing but on oxidation, which is called as fuel. Okay, or in simple, if we can say any substance which liberates energy in the form of heat on combustion is called a fuel. Even we can also define like this: a fuel is a substance which liberates energy in the form of heat on combustion. Okay, any kind we can give. So example, we have several examples: wood, petrol, coal. These all comes as example for fuel. Then next we will move on to classification of fuels. These fuels have categorized or classified based on what? First, based on the origin, how they are available. If those fuels which are available in nature, that are called natural fuels and which are considered as primary fuel, and those fuels on which are derived from the primary fuels, or the fuels which are extracted from the primary fuels, which are called synthetic fuel. So likewise, fuels have been categorized into two: primary fuels, which are also called as natural fuels; secondary fuels, which are also called as artificial or derived fuels. Then further, these primary fuels furtherly categorized based on its physical status, whether it may be solid or it is a liquid or it is a gas. So in that particular way, these primary fuels furtherly categorized as solid fuels, liquid fuels, and as well as gaseous fuel. Okay, and say example, for a natural solid fuel is wood, coal. These comes as natural solid fuels. Next comes natural liquid fuels. Example for natural liquid fuel: crude oil. Crude oil is the example for natural liquid fuel. Then comes natural gaseous fuel. CNG, compressed natural gas, is the example for natural gaseous fuel. Then coming to the secondary fuels or synthetic fuels or derived fuels, whatever names we can call. Again, these secondary fuels are also categorized same like primary fuels based on the physical status: solid, liquid, and as well as gas. So secondary solid fuel is coke. Generally, how we will get coke? From coal itself. coal, after destructive distillation, we are going to get coke, where the percentage of carbon is high in coke. So a fine grade of fuel we can call. Then comes secondary liquid fuel. In secondary liquid fuel, say yes, we have crude oil. This crude oil, on refining and fractional distillation, we are going to get several fraction of the crude. Like we will get petrol, we will get diesel, we will get kerosene, we will get petroleum ether. These all are comes under secondary liquid fuels, means which are drawn from the primary liquid fuel. Then comes secondary gaseous fuel. So secondary gaseous fuels are, of course, a product of primary liquid fuel, that is LPG, liquefied petroleum gas. That LPG also best example for the secondary fuel, which is called as oil gas also. Even biogas, from biomanure, we are going to generate some gas, that is called biogas. Likewise, so whatever fuels that are available in nature naturally are called primary fuels, and secondary fuels we are going to get on processing. After processing the first primary fuels, we are going to get the secondary fuels. So likewise, these fuels have been categorized into two. First is primary fuels, which are also called natural fuels. Secondary fuels, which are also called as derived or synthetic fuels. Further, these fuels again categorized based on their physical status: solid, liquid, gas. In primary, we have solid, liquid, gas. In secondary, we have solid, liquid, gas. Fine. And every particular species, every particular material, whatever we are not supposed to call them as fuel. There are certain characteristics it should satisfy, then only it is considered as a fuel. It may liberate energy, but all the liberating species doesn't works as a fuel here. So there are certain characteristics for a fuel. What are the characteristics we will see now? So the characteristics of fuels, the first is the fuel should available easily available fuels. Say example, coal is easily available, no extra process is required, simple extraction and usage. So coal is considered as a primary fuel and it is available easily. Next comes, it should be dry and it should have less moisture content. Why? Because depending upon the moisture content, the calorific value of the fuel will be. If moisture content is more, its efficiency decreases. That is the reason a good quality of fuel should have less moisture content and it was available in dry form. That is the second characteristic. Then third one, obviously economically available, it matters. So it should be cheap and easily transportable and has high calorific value. So the fuel should available at a commercially affordable price or cheap, then easily transport. Best example, suppose while we are transporting coal, no such measures, no high measures are not needed. Just they are going to dump that coal in the trucks. Just they'll sprinkle some water on the surface. Why? Because during transportation, if any fine particles comes, that is the reason. Just and apart from that, during transportation, there is a collision between the coal particles, slight rubbing, sometimes which will generate a heat which may catches fire due to this rubbing. So in order to avoid that, simply they'll sprinkle some water on the coal and they'll transport. So no extra care is required. Same is the case with liquid fuel. Just filling in it a container and make sure that the container was not means it not catches fire easily, then you can transport. But whereas when we are transporting gaseous fuel, we need to maintain the pressure, so it's somewhat difficult comparing with solid and as well as liquid. So in such a way, a good quality of fuel should easily transportable. and commercially available. Its calorific values must be high. Every time the ignition temperature should be moderate. That is also another criteria for a good quality of fuel. And after combustion, it should give less residue. Suppose if it is solid fuel, ash should be less. If it is a liquid fuel, the smoke which is coming out, that is should be less. So for every quality of good fuel, the amount of the final residue which comes after combustion must be less. That is also another important category. Then comes the combustion speed. Combustion speed also matters sometimes. So the combustion speed should be, it should not be very much less, it should not be very high, it should be moderate. Then a good quality of fuel, it should not burn spontaneously, because fire safety is also matter. So under a controlled conditions only, it should fire, it should burn. Then for a good quality fuel, handling should be easy, and it should not give poisonous gases after combustion. Means generally fuel after combustion, it produces some gases. That gases are called flue gases. That flue gases should not be poisonous. If it is poisonous, obviously we are not supposed to use that fuel. So it should be not poisonous. And the combustion of a good fuel should not be explosive. This is also important, because whenever we want to use that fuel in a controlled manner, if it is act as an explosive, we are not able to use such fuels. So that is the reason the combustion of good fuel should not be explosive. So likewise, these are the characteristics. First is, it should be the fuel should be available easily. Then comes, it should be dry and should have less moisture content. And obviously dry fuel increases calorific value. Then a fuel should be cheap, easily transportable, and has high calorific value. Then it must have moderate ignition temperature and should leave the less ash after combustion. Less ash means, suppose if it is a coal, less ash, but if it is liquid, obviously the exhaust, whatever exhaust gases that comes out. Then the combustion speed also moderate for a good quality fuel. Then it should not burn spontaneously to avoid the fire hazardous. Then its handling should be easy and should not give poisonous gases after combustion. And finally, the combustion of a good fuel should not be explosive. So these are the characteristics that every fuel should contain. These are the characteristics of the good fuel. Next comes calorific value of a fuel. What is calorific? See, every fuel which was graded based on the calorific value of that particular fuel. If calorific value is high, then that fuel is considered as a good quality fuel. If calorific value is low, then that fuel is considered as low quality fuel. So likewise, calorific value is one which is going to decide the quality of the fuel. Now let us come to the definition of calorific value. What is meant by calorific value? Fine. So this calorific value, it is defined as the amount of heat energy liberated on combustion of unit mass or unit volume of a fuel. Means say, if I have taken 1 ml, unit mass means 1 gram assume, or unit volume means 1 ml assume. Now this 1 gram of coal, we performed combustion for 1 gram of coal. Then how much amount of heat energy it is generating, that is called its calorific value. Or if we have taken 1 ml of petrol, diesel, or whatever liquid fuel, 1 ml we have taken, and on combustion of this 1 ml liquid fuel, how much heat energy it is producing, That is called its calorific value. In fact, the calorific value is defined as the amount of heat energy liberated on combustion of unit mass or unit volume of a fuel, which is called calorific value. And further, this calorific value is of two types. For every type of fuel, we will calculate calorific value in two forms. One is called high calorific value. This high calorific value is also called as gross calorific value. High calorific value is also called as gross calorific value. And the other one is low calorific value, which is also called as net calorific value. So in such a way, calorific value is of two types. One is high calorific value. This high calorific value is also called as gross calorific value. Another one is low calorific value, which is also called as net calorific value. Okay, so let us see in detail what is mean by gross calorific value and what is mean by net calorific value, or high calorific value is what, low calorific value is what. So let us see about high calorific value first. So high calorific value, suppose here we have taken a candle, assume it is a candle. Now this candle was burned in a closed container. Of course, oxygen, for combustion oxygen is required. The required oxygen we have supplied. So now this candle burns here and it produces some heat energy. Now after a period of time, we will cut out this flame. We are going to measure the amount of heat which was produced here. Means after some time, first what is going to happen, due to this particular flame, the entire surroundings get heated. Mean whatever gases which are present in this closed container, that gases also take the few part of this heat, whatever heat energy which are generated for this flame, which was being transferred to the surroundings. So surroundings also gets heated up. And over a period of time, again these surroundings gets cools down and give this heat back to the surroundings. So now this particular heat is called as, this particular energy is called, in this particular case, this particular energy is called gross calorific value. The gross calorific value is defined as the total amount of heat liberated when unit mass or unit volume of a fuel is burnt completely and the products are cooled. Means we are not allowing the combustion products to escape. Even whatever gas which is released here, that gas should settle here itself and it get cools down. Then that particular heat also we are going to consider. Means here we are not allowing even the trace of the heat to escape into the environment. So while calculating this high calorific value, we will burn unit mass or unit volume of a fuel in a closed chamber and the combustion products are not allowed to escape. In fact, we will make that combustion products to cools down. After cooling, we are going to take the we are going to consider its heat. So in that way, this high calorific value or gross calorific value is taken. So gross calorific value or high calorific value, it is defined as the amount of heat energy liberated when unit mass or unit volume of a fuel is burnt completely and the combustion products are allowed to cool down. Here we are even considering, due to this heat, the surrounding gases also gets heated up and we are giving some time where the surrounded gases needs to cools down. On cooling, whatever heat this gas is going to produce, that heat also we are considering. So gross, like for an employee we will say gross salary. Gross salary means the maximum that they are offering. Same is the case with gross calorific value, a maximum this fuel is going to give. Next comes low calorific value. This low calorific value is also called as net calorific value. So now I think you got an idea. Gross salary and net salary. Gross calorific value is a type of gross salary, and net calorific value means it in line with net salary. Means there are some deductions. After deductions, what we are going to get? So in case of net calorific value, that it is. The deductions are what? Here the combustion we are going to perform, the same combustion we are going to perform in open air. So obviously the combustion gases are allowed to escape into the environment. From system to surroundings, some heat will be transferred. And what is the heat energy we are considering? Only this particular heat energy which was liberated in the form of fire. This is only be considered. That is called net calorific value. So these all are the deductions. So net calorific value, it is defined as the net heat produced. Net heat means for a candle, net heat is this itself. So the net heat produced when unit mass or unit volume of the fuel burnt completely. Means when we have taken 1 ml of petrol or diesel, or 1 gram of coal, when it was burnt into the open air. But whereas while calculating high calorific value, we are performing the same combustion in a closed container. But now in an open air, in an open space, we are performing that combustion, so that the combustion products are allowed to escape for net calorific value. But for gross calorific value, we are not allowing it to escape. That is the difference between high calorific value, which is also called as gross calorific value, and low calorific value, which is also called as net calorific value. And next we have, even in a chemical, in a mathematical equation, we can also represent this high calorific value. So here high calorific value is equal to low calorific value minus 0.09 H into 587. This is the interrelationship between high calorific value and low calorific value. HCV equal to LCV minus 0.9 H, that is hydrogen, into 587 kilocalories. It is 587 kilocalories. So here what this 587 represents? It is the latent heat of water. Generally, by absorbing the heat from surrounding, water gets from the gas, whatever moisture which is present in the air, that gets heated up. Now when it cools down, so it produces some heat, that is called latent heat. Okay, so the amount of heat which is liberated on cooling of a gas or cooling of the vapor is called latent heat. So it is for water, it is 587 kilocalories that we are taking here. And on what basis we are taking? See, like this. Suppose H2O. How this H2O will get? Suppose when two hydrogens are combust by using one of oxygen, it is going to form water molecule. This is the equation. Means what it indicates here? 2 grams of hydrogen on combustion, it produces 18 grams of water. So that is a combustion product. 2 grams of hydrogen producing 18 grams of water. How about 1 gram? Obviously 9 grams. So that is what we got here. HCV equal to high calorific value equal to low calorific value plus, sorry, it is plus. What we are going to add? Plus 0.099, take 9 H into 587. 9H into 587, because 1 gram of hydrogen, 9 grams of hydrogen. But here we are going to take in the form of percentage. That is the reason HCV equal to LCV plus 0.09H into 587. This is the formula. Okay, HCV equals to LCV into 0.09. It is 9 by 100. In terms of percentage we are taking. So this is the formula. HCV equals to LCV plus 0.09H into 587 kilocalories. By this formula, we can calculate high calorific value of a fuel. Even high calorific value given, low calorific value we can calculate, low calorific value given, high calorific value we can calculate, both vice versa. So this is the formula to calculate the calorific value of a fuel. So finally, in this session, first we have studied about what is fuel, then how the fuels are categorized or classified, then what is the characteristic of a good fuel, and finally calorific value of a fuel. In calorific value, high calorific value is there, and as well as low calorific value is there, and its interconversion. Okay, thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.